Stabilization wedges. An inexpensive way to cut carbon emissions is to increase automobile efficiency. This can be done by doubling the efficiency of the world's cars from 30 miles per gallon to 60 miles per gallon. This would benefit the daily commuter or anyone who travels often. However, this poses a challenge for cars of different sizes and powers. Another way to cut carbon emitted from transportation is to reduce the miles traveled by passenger and/or freight vehicles. This would be done by cutting the miles traveled by all passenger vehicles in half. This will be a challenge for some cities because this means increased public transportation and urban design. However, this would be a positive change because it would mean less money out of the citizens' pockets. By using the best available technology in all new and existing buildings, it would be possible to inexpensively cut the fossil fuels needed to power buildings' heating, cooling, lighting, and electrical appliances. By cutting these emissions by 25% in the existing residential and commercial buildings, 1 billion tons of carbon would be kept from entering the Earth's atmosphere. Increasing power plant efficiency from 40% to 60% would be enough to eliminate another billion tons of carbon pollution. More efficient electrical production results from better turbines, using high-powered fuel cells, and from combining fuel cells and better turbines. And since the electrical production is already aided by non-carbon sources, including hydropower, solar power, and nuclear power, improved efficiency only needs to fill the remaining 65% of the wedge. Another inexpensive way to cut carbon emissions is by replacing coal-burning electric plants with natural gas plants. This would require 1,400 large, 1 billion watt natural gas plants because natural gas has lower carbon content than coal. This results in about half of the carbon previously emitted by burning coal. To remove ourselves from coal and fossil fuel dependency, wind can be used as a renewable resource to cut carbon emissions. Each year, wind power is increasing by 30%, and based on current spacing on wind farms, we will require a combined area of land the size of Germany to create a wedge's worth of power. This would be about 3% of U.S. farmland. Biofuel will be able to replace petroleum fuels by improving the world's ethanol production. Ethanol programs in the U.S. and Brazil currently produce about 20 billion gallons of biofuel per year, from corn and sugarcane. This could be seen as a challenge because there are severe land constraints. To create a wedge's worth of power, it would take about 1/6 of the world's farmland to produce sufficient amounts of crops. Halting deforestation within the next 50 years would allow more carbon to be stored in the forests. New forests would be needed to either level or reduce carbon emissions. Land about the size of the U.S. would need to be planted to achieve this result. Based on the pros, cons, and costs of each solution, I believe that each stakeholder would provide the following rankings. Taxpayers and consumers would rank my solutions as a 4 because they are cheap and require little to no work. Energy companies would give a 3 because some solutions require more work on their part. Environmental groups would give a 4 because 2 wedges require increased farmlands and forests. Manufacturers would give a 3 because one solution could possibly hinder their ability to produce and disperse goods. Industrialized country governments would give a 3 because the solutions are cheap, but they do require planning and government participation. Developing country governments would give a 2 because even though the solutions are cost-effective, they do require the participation of the government, which may not be fully functioning.